Welcome to the online ABC video tutorial. In this tutorial, I am going to demonstrate how to define an operation, and then how to add new operation needs into this operation. Here we can see a single crop project, which is being edited by the ABC. This project contains already a crop, the miscanthus. We are going to define a new operation, the plowing, and then we are going to insert it into miscanthus operations. But first, allow me to explain what exactly are the operation definitions. These definitions are being used by the ABC to describe the various cultivating operations within the same project. Usually they share common names, such as harvesting, plowing, planting, etc., but sometimes must be more descriptive, such as initial fertilization or annual spraying, etc. Generally, we encourage ABC users to use their own operation definitions only when this is required. To all other cases, it is strongly recommended to use the common operation names. Common naming is going to make any ABC project user-friendly and understandable by anyone. The important thing to know here is that operation definition itself does not contain any important information except its name. Another important feature of the operation definitions is that may be used globally within the same project. So, you define each operation once, and then you can use it with any of the crops within the project. This means that, as long as an operation definition has been created, it can be used with any of the project crops, and create totally different operations, with different operation needs, timing, and possibly different cost. You probably find useful this feature later, when you'll need to compare the operation cost results within the project crops, in order to define, for example, the most expensive harvesting, or the cheapest plowing, etc. But, let's return to our presentation. Move the mouse cursor over the operation definitions tree and select the root node. Click on the right mouse button and select New from the pop-up menu. The operations editor appears. All you have to do here is to define the new operation's name, the only required step, in order to insert it into the project. Before we do that, let's take a closer look to the operations editor form. As you can see, there are two data fields available: description and image. Ignore the image field. It will be completed automatically by the system. Select the description input, and type the name of the new operation. Finally, click on the Save button to close the form. Now, you can see plowing listed within operation definitions list. It's now time to insert the plowing into miscanthus operations. You can do that with several ways. If you prefer to use the drag and drop Windows functionality, then you can simply drag the plowing from the operation definitions tree and drop it over the miscanthus operations node. The application will request for confirmation, and if you accept, the new operation will be created. For now, let's say no, and continue with an alternative way to insert the new operation into miscanthus. As an alternative, you can select plowing from the operation definitions tree, and then right-click to show the pop-up menu. Have you noticed the new sub-menu entitled Insert to Miscanthus? Click this option, and the plowing will be added to miscanthus. It's simple, don't you think? But we haven't finished. Actually, this is just the beginning. It's now time to go deeper and set some of the properties of the new operation. Right-click over the plowing and select Edit. A new form appears, entitled Plowing Operation Analysis. This is where you should define two important things: the operation schedule, and the operation needs properties, such as the amount of man-hours, or the fuel consumption of the machinery, or even the quantities of the raw materials, etc. But first, let's define what is the operation's schedule. It is all the times that the operation is happening during crop's life cycle. The user should be able to specify this information annually. For example, an operation may be happening only the first year, the period that we prefer to call investment period, or every year, or just some specific years, let's say, under given circumstances. Before continue, I would like to distinct a special case, the annual crops. Crops with life set to 1 year are being considered by ABC as annual crops. Whenever an annual crop is being edited, the operation schedule section of the form appears disabled. In this case, user cannot modify this section. To any other case, the operation schedule section is always enabled, allowing the user to select each separate year that the operation occurs. To be more specific, the user can define each year where the operation occurs by checking the box right above this year. Accordingly, the user can exclude a year from the operations schedule by unchecking the box above this year. As you can see, the default settings have been applied to the new operation. According to these, the operation is going to happen every year during crop's life cycle. But, for our example, we wish plowing to occur only the investment year, which is the year 0. So, let's uncheck all the years except the year 0. At this point, I am not going to go any further regarding the operation needs module. We are going to demonstrate this later. So, let's close the form and move to the next step of this tutorial by demonstrating how to insert into the plowing the required operation needs. But, before we do that, allow me to explain what are these operation needs, and why do they need it for. The operation needs term is being used through this application to describe the components, or else, a set of ingredients, such as machinery, raw materials, labor, energy, and fuel, that are necessary and should be used during operations implementation. All these are cost items, and each contributes into the total cost. The operation needs have been grouped by category, and all are located to the right-down section of the ABC main window. If we take a closer look, on this side of the form we will see the machinery and equipment section, the raw materials section, the labor section, the fuel and energy section, and the rented services section. Each of these sections contain cost items that can be used to compose an operation. That's why we prefer to call these items operation needs, or just needs. An extended presentation of these operation needs groups is out of the scope of this tutorial, however, it can be found to the ABC online documentation. To begin, I shall focus to the machinery and equipment section, scroll down the machinery tree, and I shall select the plow. What I would like to do here? I would like to insert plow into the plowing operation, which I have just created. Thanks to ABC functionality, this can be done in several ways. If you prefer to use the drag and drop Windows functionality, it is available. Just select the plow node, drag it over the machinery and equipment section, and drop it over the plowing. The application will request for confirmation, and if you confirm, the new operation need will be added to plowing. For one more time, let's say no, and continue with an alternative way to do the same thing. Well, as an alternative, you can select plow from the machinery and equipment tree, and then right-click to show the pop-up menu. Have you noticed the new sub-menu entitled Insert to Plowing? Click this option, and the plow will be added to plowing. I must notice here that the second method will be available only if an operation has already been selected in the project crop operations. But, as you possibly know, plow is not enough for plowing. So, I will add a tractor that is going to drag the plow, and of course, a tractor driver who is going to drive the tractor. Let's do it. Select a tractor from the tree, and add it to the plowing. Confirm the action, and the tractor has been added to plowing needs. But just a second. Something else added at the same time. The fuel. ABC can auto-identify if the machinery needs any kind of fuel, and so, tractor's fuel inserted it to the operation without any further instruction. This is very helpful, especially because ensures that the user will not miss it. Now it is time to insert the driver into the ploughing. Let's do it. Go to Labor tab and select the preferred labor type. Right-click the mouse to show pop-up menu and select Insert into ploughing. Confirm the action, and that's it. Now, all required operation needs have been added to the ploughing. But we haven't finished. There is a final step left, and we can understand it easily if we take a closer look to the operations cost analysis card. We can notice that ABC has not produced any costs for ploughing. Why? Because none of the operation needs properties have been defined yet. In other words, we must define how much time is needed by the driver to drive the tractor, and what is the fuel consumption of the tractor. To define this information, right-click over the ploughing node within the Miscanthus operations and select Edit to open the Operation Analysis Editor. Take a look at the Operation Needs section of the form. The operation needs we have just added to ploughing are now being displayed within the data grid. Notice here that each need description appears underlined. Click on it, and a tooltip appears with additional information. Let's go to the amount column. This is where we should define the property values for each operation need. The unit column, which is being displayed right after the amount column, it can help us to understand what type of data are expected. So, for the first operation need, the plough, we know that we need 2 hours per hectare, and so we type 2 in the amount column. The new value is being accepted by the ABC calculation engine, and the cost appears accordingly to the cost column. But, just a second. What is this cost? Plough is just a tool. It does not need fuel or other energy to function, so where this cost comes from. It's now time to go deeper, once more, and describe some of the ABC cost analysis theory. We have here Anna, our financial advisor, to explain a bit of ABC methodology.
Hello. According to the ABC methodology, the total cost related to machinery and equipment is the sum of economic depreciation, opportunity cost of holding the asset, for example, interest, maintenance cost, insurance, fuel, and operator's cost. The last two factors, as I mentioned, are reported separately. Economic depreciation, as you probably know, is the loss of value during the period, due to breakage, wear and tear, technological devaluation, etc. In general, it is the difference between the value of the asset at the beginning and at the end of the period. Economic depreciation reflects the service reduction capacity and the change in the price of the capital asset. ABC approaches these cost items, calculating the capital service cost of the machinery. The capital service cost consists of annual equivalent cost of depreciation, in other words, the opportunity cost of holding the asset, for example, the interest or cost of capital captured in the asset during its useful economic life, plus annual maintenance, plus annual insurance costs.
Thank you, Anna. Now, let's return to our project. After this brief financial analysis, it will be probably much easier to understand where this cost came from, and why it has been charged to the plough machine. Now we can continue. The second cost item we can see within the Operation Needs Editor is the tractor machine. Now we must define the amount of hours per hectare needed by the tractor. We set 2 hours into our example. The next step is to define the amount property for the next cost item, the fuel for tractor. We notice here that the type column is set to energy, defining that this cost item has been come from the energy tree, and that the amount has been set to litre per hectare, accordingly defining that here is expected to be added the fuel consumption of the tractor. Let's define it, and proceed to the next and final step, which is to define how much time is needed by the labor, in our case the driver of the tractor, to drive the tractor. We can notice that unit has been set to hours per hectare. So we set 2 hours into the amount, and we finished. We can see that ABC produced the final operation cost. It is important to remember that all cost items within this procedure have been annualized and that the total cost is the annual equivalent cost of the operation. Finally, I would like to demonstrate how flexible is the operation scheduler, and how easily the user can monitor the operation's cost modifications, simply changing the operations schedule. Just check the box below the required year, and the operations cost will be increased accordingly. If, now, you uncheck it, the cost will be recalculated. As we can see, the user has the absolute control of the operation's timing and needs through the operation editor. One last thing to say about the operations editor is that all user changes and settings are being saved automatically upon the time they are happening. So there is no save button. Let's press the close button to close the form and return to the main form. To ensure that everything went as expected, we can focus on the project tree, miscanthus, and select with the mouse the plow under the operations node. Now, take a look at the right panel, where the global cost analysis layout report is being displayed. There is an animated chart on the top of this panel, displaying the cost analysis by factor sliced pie chart, and then, below, there is the miscanthus cost analysis data table. Within that table, we can see the cost analysis by factor, displayed in annual equivalent values. Notice here that subsidies have been excluded from the total cost, and they have been reported separately, at the end of the table, and after the total cost. This is happening because of the reverse logic that they have. Subsidies are influencing production decisions, but are external to the financial mechanism and identity of production. So, it is important to isolate the effect of subsidies by entering these amounts at the bottom of the cost analysis separate from the actual cost. Continuing the description of the cost analysis layout report, we can see the operation cost analysis data table. The costs displayed within are not related to the total cost analysis report. They are related to the selected operation within the project tree, and displayed only if an operation, or overhead, or subsidy has been selected. So, whenever we want to check up for an operations cost analysis breakdown, we can simply select it on the project tree, and the related information will be displayed on the cost analysis report panel. At this point, we have reached the end of this tutorial. We hope that we have presented with the most efficient way some of the most important features of the ABC. Do not forget to visit our website and check for other available tutorials. Thank you for using ABC software.